Right then, time for our final look at the new features that have come into the C# language with version 10. And the area we're going to look at this time is a few minor changes in the realm of Lambda expressions. Nothing absolutely earth-shattering, but like a number of the other ones we've seen in those two earlier videos, they are related to making the language a bit more consistent so that when you could do something in one situation and you might expect to be able to do it in a similar situation, previously there were a few little quirks over that, and that's what we're going to sort out. And so what we're going to be looking at is an application I've put together here, very simple stuff, where I've got this class called worker. And worker simply is a list of actions. So that's our delegate, takes no parameters, returns void, simply action. And then we have this run that loops through the actions and invokes each one of them. And the sort of situation where you might use this, I would use this in something maybe like a web job where perhaps you've got a website that needs to have some daily activity. So you might set up a web job to run at 5 o'clock in the morning to send out emails and then maybe to run some reports or maybe to tidy up some temp files or something like that. And so we could add those tasks into here. So here in the program, remember this is using the new style of program that doesn't actually need the class and the main explicitly in there, but I've created the worker and I've run it. And then just to show the sort of thing we could do, I could do worker.actions.add, and then I could use here a lambda, which is what we're talking about. So remember, it takes no parameters, and all I'll do here is we'll just have a console write line. Don't need that global system in there, it's being a bit over generous. And then we can just say send the daily emails. And then let's have another one of those. So let's have an additional one. Tidy up the temp files. So simple enough. And then when we run that and bring over the console, we can see it's just done both of those. So very simple stuff in there. But now we can look at some of the limitations and some of the other things we might want to do with that, because we there have taken our lambda and popped it straight into the parameter for add, and of course add we know is going to take an action because it's a list of actions. But what if we wanted to store that up in some way? What we might want to do is we could say something like var act1 equals, and then maybe pop in the lambda that we want. And you can see it's giving us an error there, and as so often it's saying why don't you upgrade to C# version 10, because I have once again deliberately set this at the older version 9, and the problem there was that you can't infer the type of a lambda, so we can't put var there. In this case we would have had to put action. And now that's all perfectly okay. Not a huge problem there, but in more complicated situations, if I were to say something like var func1 equals, and then maybe something like, again, let's start with no parameters, gives, and then let's just say 42. Again, even though we could see that is clearly a func returning an integer, it's not able to infer it, and so we would have to put in func int on that, and that's perfectly happy. But now in C# 10, if I change that, obviously that still all works, it's all backwards compatible, but I can now also put in var there and var there, and it's perfectly happy. It works out what's going on there. So if I hover over func1, we can see it's worked out exactly the same thing. It's a func with a return type of int. It's also, you'll notice, declared as nullable. And then on our act1, it's worked out that that's an action, and that's what we have there. When we're dealing with functions, things could get a bit more complicated than that, however, because if I do something like this, if I said var func2 and then gave it a parameter, so let's say x gives x times 2, now again we've got a problem because there's no way it can infer what x is. If I'd done this explicitly, saying it takes an int and it returns an int, then that's all fine, and now it can tell from the context, because we've said it's taking an int, that x must be an int. But if you've got var there is simply not enough information. But we already know you can actually declare the type of the parameters on a lambda. Normally it's inferred, so normally you wouldn't bother with doing this, but in this case it's not. And so now we can see that we have that working correctly, and it's a func int. Now, so far, all the ones we've seen have actually just matched one of the available overloads, either for action or for func. But that doesn't cover absolutely all of them. What if, for example, we decided to say we wanted to pass x by reference? Now, that is not supported directly by the func overloads. And so now if we look at that, you can see that it's still managed to create it as an anonymous delegate type. So it hasn't used one of the predefined ones, but it's still happy to make that work, and we could use that without having to declare it. Other things that we can do with this inference, there are situations when the return type itself might be ambiguous. So suppose I did something like this. If I said var func3 equals, and let's have a int x as a parameter, and then what we're going to say is x is greater than 10, question mark, so use the ternary operator, and let's stick with that 42, but then also return 42. And we now have a problem that it can't determine the return type of that particular expression. Now, it may seem a bit odd. Well, how can we possibly do that? But remember, what we could return from that is any common base class or interface that both int and string have. So we could have done this something like this. We could have said func, and then the parameter, remember, is an int. And then if we did something like iComparable, then because both int and string implement iComparable, then that's all okay. It's allowed to do that. But we're trying to infer this, and so in order to do that, we actually need to specify a return type on the Lambda expression. And you do that by putting it just here before the open round brackets. Starting to get a little bit weird, but it's logical, I think, in terms of syntax. So that is now a very explicit Lambda, not something we normally do. And in fact, we want to avoid this because the real benefit of Lambdas is they're really good at inferring both the parameter types and the return type. But if we want to infer the entire function type, then you've got to do this. So there we have the parameter type, and that is the return type. But only if it's not possible to infer it. If we were doing 42 and 43, then that's perfectly okay. They're both ints, and so it can infer it with no trouble at all. One other thing related to this, actually, inferring the types not of lambdas, but of other types of delegates. So, for example, if we go back to version 9, give that a quick build, and then put in here var func4 equals math.sign, then you can see it's having trouble again that it can't infer the type. We would have had to put func, and in that case, double. Very similar to actually the video I did quite a while ago on lambdas. And so we could do that, but again, if we move up to version 10 and build that, then it can work it out for us. So just a number of things. Some of them really do make the code easier to read. Others, I think, when you're starting to have to put return types onto the Lambda anyway, you might as well just declare the func3 or whatever it was explicitly rather than trying to get it all to be inferred. But it certainly means that things behave more consistently. Now, the other thing that we've now got in all of this, again, trying to make lambdas as much as possible like regular functions, is that we have the ability to do attributes on lambdas. So since time immemorial, we've been able to do attributes on methods and things like that, but now we can actually have attributes on lambdas. So let's put that together, because one of the problems we've got with this idea of the worker is that when you run the worker, everything you've put in there just gets run. And so if this were running at 5 o'clock in the morning, everything would happen. And it may be that certain things you don't want to happen every day. So for example, sending emails, that might be something you only want to happen on weekdays and not weekends, whereas tidying up the temp files you want to happen every day. So there's various ways we could do this, but the way I'm going to do it is with attributes. So what I'll do is add a class, and I'm going to call this scheduler attribute, and I'm going to make it public, and I'm going to derive it obviously from attribute, and I'm also going to give it an attribute target. So we're going to have target of method in this case. We're not going to allow multiple, and we also are going to say this is inherited. We'll see why in just a moment. So that's all of that. Because what I'm also going to do is actually make this an abstract class, and I'm going to put on it an abstract method, and this is going to return a bool, and is going to be called canRun, and is going to take a date time as a parameter. So given a particular date, should we be running this particular task? And I've made that a base class because there's all sorts of different rules to when it should be run. You might have things that run once a year or once a month. And so I'm just going to do one example of a derived class. So let's add another class that I'm going to call weekday scheduler attribute and make that public. Derive that from scheduler attribute. Implement the abstract class. And then what I'm going to do in here is just, let's use an arrow function. And I'm just going to say date dot day of week. And then I'm going to use the pattern matching that was introduced, can't remember when, a couple of versions back. So I can do something really neat here. I can say is, and then greater than or equal to day of week dot, in this case I want Monday, and less than or equal to day of week dot Friday. So that will give us our scheduler. And then what I can do with that is back in the program, I can now apply that to the send daily email. So on here, I could simply put weekday scheduler, just like you could on a method. And I wouldn't have been able to do that. Again, let's just flip back. So if I had done that in version 9 and do a build, then we can see same thing. Why don't you upgrade to version 10? That obviously is an attribute that's being applied simply to the method itself. But if we take a look at some of the other things you might do, and in fact, just to make life a bit easier, let's temporarily remove that target. So now, in general terms, we could apply it to anything. And then if we go back into program, and let's just do another one of these. So in this case, I'm going to do it explicitly. So let's have a func int, call this func5. And then here, we're just going to have equals, and we're going to put something like x gives x times 2. And now let's try and apply the weekday scheduler to that. Doesn't make a lot of sense, but it should be legal. But you can see we've got a problem with that one, and telling us we require a parenthesized parameter list. The problem is it's impossible to tell for the compiler whether we're trying to apply that attribute to the entire Lambda or whether we're trying to apply it to the parameter. Because remember, we can apply attributes to parameters as well. And so when you're doing this, you've got to put in the brackets. So either we would put in brackets looking like that, in which case it's applying to the parameter, or we could put it like that, in which case it's applying to the entire Lambda. You can have multiple attributes just in the same way that you would traditionally. You can also, it's not a very common thing to have, but it's not really new, but on a Lambda you can have a attribute on the return type, which in that case, again, doesn't make a lot of sense in this example, but that's the syntax we have. But we have, most importantly, this ability that we can put this one, the weekday scheduler, on our send the daily emails. Now, it's not really anything to do with the new features of C#10, but let's just implement that. So we need to go into our worker, and then here we are looping through our actions. So now we've got to have a look at the scheduler. So what we do here is, firstly, I'm going to say var attr for attribute equals action. Now, the thing you might expect to do here would be to do something like action.getType. And then on the type, we could do getCustomAttribute. And then we could put in the type of the attribute, which we wanted to be our scheduler attribute. So we're going for the base class here so that it will pull in weekday schedulers or any other kind of scheduler that we may have gone for. But actually that's not the right thing to do, because when you're dealing with delegates, so actions or functs or whatever they may be, the attribute is not actually applied directly to this action object itself. What we have to do is say action.method.getCustomAttribute. And the method is a object of type method info, so it's what you ultimately could get out of the type, but then that's the thing that we want to apply that. That reminds me, we do need to just, for completeness, put that back in so it can only apply to methods. So that's the thing to watch out for. Again, nothing new, nothing specifically to do with lambdas, but when you're dealing with any kind of delegate, if you want to get the attribute of a method, then you do it like this. Then having done that, what we've got to remember there is obviously that attribute could be null if it's not found it at all. So we need to do a test, and we're going to say actually if attribute equals null, so if we don't find a scheduler at all, we just run the action. We're not going to say it has to have one. If it doesn't have one, that defaults to mean run it every day. So we say if it equals null, or, and then we say attr dot, and then remember we've got that abstract method can run, to which we pass in a date. So if I just do datetime dot UTC now, then that gets passed in, and remember our weekday scheduler will make sure it's a weekday. And so that really should get that all working. So if we run that up, we can see that because today happens to be a weekday, it's a Wednesday, we've got both of those listed there. So what I could do just to prove it's working is a little bit of a cheat. If I just do something like minus new time span, and then let's put this 3 days in the past, so 3, 0, 0, 0, that's the correct overload. And now if we run that one and bring that over there, now we can see it's done the tidy up because that didn't have a scheduler at all, but it hasn't done the weekday because with that time change with the weekend. So, as I say, that's my last look as far as I'm concerned at C#10. There are a few other features in there, but none of them really impact what you actually do in terms of programming very much. They're more under the covers, some performance improvements and associated things, but unless you're really interested, in which case let me know in the comments. I'm not going to look at those. What I am going to be looking at though is in future a number of the new features that have come in .NET 6. So things that aren't actually language features, but features of the .NET library that can make a big difference to how we program. So we'll be looking at those in several videos coming up. But if you like that, do click like, do subscribe, and I'll see you next time.